Hello friends, welcome to engineering tutorial. Today we are going to discuss about an important part of electrical and electronics engineering, an important branch of electrical and electronics engineering, that is control system. So it's a very important topic which we are going to start today. So let's just first understand the basics, some of the basic concepts associated with control systems. Now let us first try to understand what is a control system, what is its basic definition. Now a control system is a combination or a collection of elements which are arranged and connected in a proper and planned way, where each and every element which is associated with the control system has its own effect, has its own impact, and it manipulates the process to produce an output which is desired by us. So each element or each block has its own effect which produces the desired output. Now the control systems which we come across in industries or day-to-day life situations, they are primarily designed in order to get the desired output. Okay, if you want 5 volt of output voltage to drive an equipment, or if you want 12 volt to drive an equipment, you want 12 volt only. You don't want greater than 12 volt, or you don't want lesser than 12 volt, or more than 5 volt or lesser than 5 volt. You want 12 volt exactly. That is what the control system does. The control systems are associated with all the equipments, all the gadgets, all the appliances that we use in our day-to-day life. So it's a very important thing. Now the next thing which comes to discussion is the classification of control systems. Now the control systems, they can be classified into 2 categories. Broadly they can be classified into 2 categories. First is the open loop control systems and the closed loop control systems. They are classified, this classification is based on one criteria, that is feedback, the feedback connection between the output and the input, the connection between the output terminal and the input terminal. So there are 2 types of control systems, the open loop control system and the closed loop control system. Now this is the basic layout of an open loop control system. Here there are 2 blocks, the process and the controller. Now the process is a continuous series of actions or operations which produces a desired response, the desired output. Okay, now the process can be you can consider a nuclear reactor or a thermal power plant or a hydropower plant, anything, any industrial process which has a control system associated with it. So that is what a process is. It gives the desired output. Now the next block is the controller. Now the controller is that element which guides this process, this operation, so that we get the desired output. It manipulates the process, it makes certain changes in the process dynamics so that we get the desired output. Now I said earlier that In open loop system, there is no connection between the output and the input. That is, there is no feedback from the output to the input. It's not automated, it's not automatic. There is no automatic change, it's completely manual. Everything is done manually. It's human controlled completely. Okay, so there is no feedback. The input is given to the controller, and the controller, depending upon the control law associated with it, manipulates the process to give the desired output. So this is the open loop control system. Next is the closed loop control system. Now this is the basic layout of the closed loop control system. Now you see there are a few changes that have happened here. There is this process block and controller block which were present in the open loop control system. Now there is this feedback connection from the output to the input. So wherever this feedback connection is present, we call it a closed loop control system, as there is a closed loop which is formed here from the output to the input. This is this closed loop, and this one is the error detector, or you can call it a comparator. It compares the actual output of the process, that is the output which is produced actually, with the desired output, the output which we require. So it compares the two signals, the actual output with the desired output. Now this desired output value is called as the reference or set point. Now there is also this amplifier block which amplifies the error signal. As this error signal is of very low magnitude, so it has to be amplified so that it can be fed to the controller to make certain changes to the process depending upon the error signal. So as there is a feedback connection from the output back to the input, a closed loop path is formed. That's why it's called a closed loop control system. Now let us compare the open loop control system with the closed loop control systems. First, the advantages and disadvantages of the open loop control systems. Now obviously the open loop control systems are simple because there is nothing, there is no feedback connection, there is no feedback loop which is formed, there is no error detector, no comparison, anything. So it's plain simple thing, it's completely manual. Then as there is no feedback connection and no additional equipments are required, it is comparatively less expensive as compared to the closed loop control system. And as less number of equipments are there, so obviously less maintenance will be required, and proper calibration is also not required as it's not automated, it's completely manual, so it's driven by a human being. So there is no proper calibration of each and every block required because the operations are not automated. The disadvantage is that as the human factor is involved, there is room, there is possibility for inaccuracy, errors are going to happen. There is chances of errors because the human factor is involved, and wherever the human factor is involved, there are possibilities for error. And obviously as they are inaccurate, as there are high chances of the occurrence of error, they are not reliable. Okay, and another disadvantage is that optimization, that is achieving a balance between the maximum possible output with minimum possible input, that is not possible in case of open loop control system. So these are the disadvantages. Now let us see the advantages of closed loop. These are completely opposite to that of open loop, that is they are accurate, they are reliable, There the optimization is possible to achieve the maximum possible output with the minimum possible input. As the entire operations are automated, so accuracy is improved greatly by a large factor, and as accuracy is improved, the reliability of the open loop systems, the closed loop systems is more. And the disadvantages is that as there are a lot of complicated connections between the output and the input, the feedback connections, they are a little bit complicated to design and install. And as more number of equipments are involved, they are expensive and more maintenance are required as there are more number of components involved. So these are some of the advantages and disadvantages associated with the open loop and closed loop systems. Now another thing which is important is that it is not that the closed loop systems are accurate, that's why they have to be used everywhere. It depends on what are the type of operations that you are going to do. In some cases you have to use open loop systems, in some cases you have to use closed loop systems. It depends on the requirement and various other factors such as cost, then the type of operation, the amount of accuracy which we require. So there has to be a balance obtained between the various factors. So depending upon that, we have to decide whether we have to use the open loop and closed loop control systems. Obviously the closed loop control system has the upper hand. It has various advantages as compared to the open loop systems, but still we have to decide in which case we have to use which type of control system. So here I have discussed with you some of the basic concepts related to the classification of control systems. Let us look at a comparison between the open loop and closed loop control systems. So we are going to compare the two types of control systems on the basis of various factors. So the main factor which separates the open loop from the closed loop is the presence of feedback. In open loop there is no feedback path present between the output and the input, whereas in closed loop there is a feedback path present. Now in open loop, because of the absence of the feedback path and the comparator or the error detector, the design criteria, it's very simple, and installation is also very simple. Whereas in closed loop it's the opposite. Because of the feedback path and the comparator, the design becomes a little bit complicated, and also the installation in the process or the environment, it becomes a bit tricky. Of course in open loop less components are involved, in closed loop more components are involved. Because of less components, the cost is less. In closed loop the cost is more. And in open loop, as the operation is based on the human factor is involved, it's less accurate and hence it's less reliable. Whereas in closed loop the entire system is automatic, it's not manual, it's automatic. Everything is automated because of the feedback and the error detector. So as a result of it, it becomes more accurate and more reliable. Now however, the open loop system, the open loop control system is more stable because it is less sensitive to the external parameter variations, and because of the absence of the feedback path, it is less sensitive to parameter variations. We will discuss it in the later discussions, but generally the open loop control system is more stable, whereas the closed loop system is less stable. Also we discussed in the advantages and disadvantages that the optimization, achieving the maximum possible output with the minimum applied input, it is not possible to achieve optimization in open loop, whereas it is possible in closed loop system. And as less components are involved in open loop system, the power requirement is less, and the power requirement is more in closed loop system because of the presence of more components. So here it is a basic comparison between the open loop and closed loop systems. Okay. Now let us discuss about the concept of transfer function. Now, what is a transfer function? Whether it's a open loop system or a closed loop system, in general for a control system, the transfer function is the ratio between the output, this is the output, and the input value in the S domain. Okay, it is the ratio between the output and the input in the S domain. Now, how you get the S domain of the input and output signal? Simple, through Laplace transform. By taking the Laplace transform of the time domain input and output signals, you get the S domain representation of the input and output. Okay, the transfer function is the ratio between the output to the input, Cs by Rs, which is the output, Cs is the output, Rs is the input. In S domain, it is the transfer function. Now, mind you, this is the open loop transfer function, there is no feedback path involved. Now, this is the gain, or the output by input, we know it is gain. So, this is the gain of the system in the S domain. And another thing to take care while calculating the transfer function is that all the initial conditions must be set to 0. It means that at the time t equals to 0, which means the beginning, at the start, the values of the output, it must be 0. There should not be any residual value of output. All the initial conditions must be set to 0. There should not be any residual values. Now, this is the open loop transfer function in which there is no feedback path. It is simple, the gain of the block, the gain of the forward path. This is the forward path. There is no feedback path. So, simple, Cs by Rs means output by input, it is Gs, the gain of the system, the gain of the forward path. For a closed loop system in which there is a feedback path. Now, here the gain of the forward path is Gs, whereas the gain of the feedback path, it is Hs in the S domain, the S domain representation. Now, here is the comparator or the error detector. This is the input in S domain, this is the output in S domain. So, here the transfer function is calculated by this formula, Gs by 1 plus minus Gs Hs. Now, please look here carefully. Here I have taken this symbol first minus then plus, but in here I have taken first the plus sign then the minus sign. It means that when the sign here is negative, here the sign will be positive, reverse, and when the sign here will be positive, when it will be positive means the two signals will be added. Here this sign will be negative. Okay, please listen to me again carefully. When here at the summer or the comparator or the error detector, whatever you call it, when the sign here is negative, means the two signals are subtracted. In that case, here it will be GS by 1 plus GSHS. When these two signals will be added, means the sign here will be positive. The transfer function, which is the output by input, which is CS by RS in S domain, it will be GS by 1 minus GSHS. So it's opposite. When the sign here is negative, it will be positive. When it's positive, here it will be negative. Just the opposite. So this is the formula, the gain of the forward path by 1 plus or minus, depending upon the sign here, into the product of the gain of the forward path and the gain of the feedback path. And another important thing again, while you are calculating the transfer function, that is the ratio between the output and the input, make sure that all the initial conditions are set to 0, which means that they at the beginning, at the start, at time t equals to 0, all the values must be, or associated with the control system, it must be 0. There should not be any residual value. So in this video I have shared with you some of the basic concepts related with control systems. I hope you like this video, and please subscribe my channel for more such videos related to electrical and electronics engineering. Have a great day. Thank you very much.